Hi, welcome back. In this set of videos, we're going to be looking at section 7.4 in our book, which is confidence intervals for variance and standard deviation. When we look at variance and standard deviation and we make confidence intervals, we're going to be thinking about the same type of process that we used in our other situations where we have a point estimate for our parameter. In the case of the parameter of variance, we're going to estimate this with population variance, and for population standard deviation, we'll estimate with sample standard deviation. So same things, or kind of as expected from the previous sections. Those will be our best point estimates. But standard deviation and variance do not follow the normal distribution or the student t-distribution, so we have to learn about a new distribution. The new distribution is called the chi-square distribution, and it's similar to the t-distribution in that it's a family of curves, but it's not like the normal or the t-distribution in that it's not a normal or it's not symmetric distribution. And so this is kind of 4 of the different curves. We have degrees of freedom 1, 4, 9, and 15, and you can see that the shape of the curves, while having some similarities, is quite different. But it's also very different from our normal distribution. So our 4 criteria, or some 4 properties of chi-square distributions, all chi-square distributions, or all chi-square values are greater than or equal to 0. So all chi-square values are greater than or equal to 0. That means there are no negative chi-square. And if you think about the symbol chi-square, we've got something squared. Things that are squared aren't negative. So this value over here, this left limit, is 0. The next thing is that it is a family of curves based on degrees of freedom. So family of curves based on degrees of freedom is something we talked about when we looked at our student t-distribution, but we need to talk about them again when we look at our chi-square distribution. It's a family of curves based on our degrees of freedom. In the case of these problems, or when we're looking at confidence intervals for variance and standard deviation, we're going to use a degrees of freedom n-1. This will not always be the case for our degrees of freedom, but for these problems, that's the degrees of freedom. Later on in the year, when we start looking at some different tests and situations that use chi-square distribution, they won't have the same degrees of freedom. They'll have a different formula. The area under all curves, the area under each curve is equal to 1. Each of these curves has a total area underneath them equal to 1. And all of the curves have positive skew, or they are skew right. This is very different from the normal or the t-distribution when we had a symmetrical distribution. Now, with the normal distribution and the t-distribution, I was able to go to my calculator and use my calculator. If you go to your calculator and you look under distributions, you'll see that we have chi-square PDF and chi-square CDF. I believe that the TI-83s do not have chi-square built in. They might, but I don't think they do. But it's really not that useful because this is a chi-square CDF. So this is going to give me, this is asking, if I have some limits on my chi-square axis, it will tell me the area under the curve. And what we've been doing when we're looking for a critical value is we have an area under the curve and we want a value, a chi-square value, so we're not going to be able to use the calculator. So I'm going to put the calculator aside for now. So if I look, this is my copy of the chi-square distribution that I have marked up. Here is a blank copy. We'll look at the blank copy first and then I'll bring out mine. The way this table works is on the left-hand side we have degrees of freedom. You'll notice they go up by 1 until you get to 30, and then they jump by 10s all the way up to 100. And alpha values are marked across the top. But if we look at this picture, alpha is area to the right of some value. In all of our other tables, it's been area to the left This is now area to the right. You'll also notice that it doesn't have all of the areas, so we need to be careful with how we use this. Let's talk about how we might use the table, and we're going to use the table to find critical values. So when we're finding critical values, we're going to find these two values. So I'm going to know area outside. I'm going to need to find area to the right to use this table. So if I know my degrees of freedom, like if I know 14 degrees of freedom and an area to the right of 0.025, I could get a chi-square value of 26.119. In our next video, we'll look at this a little bit more carefully, see how to use the table while solving for critical values.